What's up? Welcome back. Today we're working on my to-do file system. Hold on, let's just pop them open on GitHub here. To-do FS. And the idea behind this project is I have like files on my disk, and they have like maybe relationships with each other, right? So I have like lists of things that I want to do, and maybe like I have two things that are part of like my terminal emulator project, and one blocks another. So I might want to be able to like display, these things as like, I have like Termy, my project, and he's like linked to like task A and B, and both of these guys are like tickets of Termy, and so I want to like be able to see that. But I might also want to see that like, A blocks B, and I might also want to be able to see that like, okay, like what about like things that are finished? Well, let's like group those. Finished. And so like then I want to be able to say like, okay, well now B is finished, and so now I want to be able to see like this like complex view of data that is like, show me A, like if I want, show me tickets of Termy that are unblocked, right? So if B is finished, then I can work on A, and I can know that because like the relationships all kind of like match each other in that way. And so the previous way of me like storing things on file system is like kind of tricky because like maintaining that like state of like who blocks what and what do I have to do first, all of that stuff becomes like kind of hard to deal with, and especially if I want to plan more than a couple days out, then it becomes kind of hard. So that's kind of like the idea behind the project is I just want like one source of truth for the data, a database, and I want to be able to like navigate that source of truth in like different ways, right? So maintain a bunch of you could say, well, I can just maintain a bunch of symlinks, but then every time I change something, I have to remember all of the symlinks that each thing affects. So I want to build up like rules, basically, that say like, show me this set of things if that set of things, etc. So let's see. I just built this. I haven't run it on this account for a second, so let me just see if I can remember how to run it. Cargo run. I think it's bin to do fs, and then I specify the database is this thing, and the mount point. Maybe I'll write help. DB path not provided. This is really bad UX, so let me just check the argument parsing. It's db path. Okay, so it's db path to do fsdb, and then I give it fuse options to my mount point, which is we'll call it makedir to do. Okay, so we will mount this like database on this point, and we'll run it in debug mode so we can see things. Okay, so it's mounted, and I should now be able to go into here, and I have like this like flat list of items. These are all of the like things that I want to store, and each of one of these guys has like a subfolder where I can put like any form of data that I want. And I happen to be putting things called like description.md by convention, but it could be anything. I could like use this for generic document storage of any type. And then I have like this like filter that says, hey, I want to show all items from this flat list that do not have a parent. So that ends up being like projects essentially, right? So I can look at like my Termy project, and I can see like, oh, I have these things, and these guys all symlink back to like the root thing. Where this gets kind of tricky is right now, there's no way for me to say, okay, when I finish something, first of all, I haven't explained something. The file system hopefully has no idea that it is a to-do file system, right? I kind of want to keep the idea that I'm using this as like a ticketing system abstract to like the code base itself, so that it can be also used as like a wiki later if I want it to be. So if I want to like say, okay, one of these things is finished. I did readline support yesterday. The way I'm kind of thinking of doing that is that I would like assign it to like this finished state over here, and maybe to like fix some of the filters, maybe finished lives in like a state parent or something. Who knows? It doesn't really matter. But the idea is that I want to be able to say this is finished, and then I need to be able to say, show me in this view of Termy, the project I'm looking at, show me children that are not finished. That's like an important thing for me to be able to look at. And so that's what I want to implement today. And I was thinking like, well, what's like the way to implement that? Because right now, when we go into these projects, these guys are just like links back to items, and these items are like raw. They're kind of like the same in every view. And like right now they show relationships. So if they have children, it will show parents or children, right, as part of the thing. but I would also be able to like tack on things, right? So if I'm a project, I want to see children that are not finished. Great. And so the question is, how do that generically? Right? And so I was thinking, well, I could like tag termy. I could say, hey, termy is a project. Project. And then I could say, well, if termy has the tag project, then I'm going to apply this filter. In the same way that I'm saying, like, at the root level, I have this like show me items that have no parents. I could apply like another filter to this item if it has this tag. And then I was like, well, maybe like the tags, I don't really want to implement tags right now because I think that I think tags are like a specific form of relationship, right? I think that a tag is the same thing as saying, give me an item project over here. And I think the tag is the same thing as termy is a child of project. That's like kind of like the same concept as tagging, except it's just like, there's no extra code needed to like facilitate that. And so then I was like, okay, well, what is like a generic way to do this? I want like items to have filters, and I want those filters to be shared between multiple objects, multiple items. Like, right, I want all projects to show the same set of filters underneath. And so what I was thinking is, you could have like filters that apply to items unconditional, like based off of some condition, right? So I could say, if my item is a project by like some condition, then show tickets by this filter. And then I can start saying, okay, so then show me children of myself that are unfinished. I think that will work out. And so I think that this like idea turns into a concept of like conditional filters, right? I want to apply filters to items if a condition is met. And so I think that we can do that, right? I think we already have kind of the concept of a condition. We call it the filter right now. We have this like, right, we have this projects thing, which is a filter. And we can just say all of the things that we currently call like filters, we'll just make them conditions. And then we can apply a condition either to, if the condition matches, then I run a second set of filters. I think that'll work out, I think. But who fucking knows? So I want to try that. I want to try it. Umount to do. So let's kill this guy and kind of get into the code and see what that looks like. Okay. So the way all this works, do I have this open already? I do. Okay. Hold on. Before we get too far into this, let's do some accounting. So intro done, and it is 7:45. And the first thing we want to do is adjust the filter concept to be a generic condition. So the way this works is we have like a database, and the database will actually store. Do I have? I don't. Fuck. Hold on. I want to open the database. So let's install SQLite browser just so we can take a look. Give it a sec. Give it a sec. He's got to do some thinking. He's got to go to the internet. SQLite browser to do fsdb metadata. Okay, so the way like this works is our database has a like filters table. And right now I only have one filter. He's like the project filter. And there's no like data associated with this. You're like, well, how does it know what to do? And each type of filter says like, hey, I'm part of filter ID 1. So we say, okay, we have filter ID 1 project, and we have these like no relationship filters. And this says like, okay, so I want to make sure that I'm on like, show me tickets that do not have a relationship where I am the destination of relationship ID 1 is basically what this says. Where relationship ID is the concept of parent-child. This database has a little bit of garbage shit in here, but that's fine. That's fine. So if we open up our database, we like reload those from disk, and we parse them into something. Let me find it. Let's see. Filter. Item filter rule. So this guy has no relationship, and we're gonna have to like extend this a little bit to have like whatever conditions that we're gonna need, but we can do that later. I think maybe the first thing we want to do is let's see if we can just, maybe item filter rule is like a too specific of a name now, right? What this really is a condition. So we call this like ticket condition or something. No, it's not ticket. There's no concept of tickets in the code base. Item condition. Maybe we just call it condition. What does that look like? Yeah, not crazy. Not crazy. Where is this used? This is used in database, fuse, and create filter. So fuse is like where like the file system conversion lives. So we can just look for that. Git diff fuse. What is he using it for? He's got some like serialization shit. Sure. Oh, I see. It's for like so we have like binaries bundled with the file system that allow us to like do more complex actions. And those use like a socket. I put it in quotes. It's not really a socket, but it's kind of a socket. It's like a fake file that you can read and write to, like you would a socket. So there's like an API there. So I think that's fine. We can just adjust. I think renaming the existing item filter rule to condition is probably fine. Do we need to update the database tables? What do those look like? Those said no relationship filters. Maybe I'll start implementing the condition thing first, and then we can see how the database needs to look. So let's see. What does that look like? So we'll kind of call this like semi-done, and we'll say add condition to flag if filter should be applied to an item. Okay. So what does that mean? What does that mean? So I'm going to say something like, hey, I have an item. Let's see. I am going to want to say, if my item has no parents, apply filter 3, right? Maybe we'll have filters set up and we can just reapply them. Okay, so that seems reasonable. And like, what does that look like? What does that look like? Item has no parents, apply filter 3. So we're going to, I guess, maybe I'll start looking at it from like the file system side of things, because I think that will kind of guide how we're going to use this, and then it will kind of make me understand the rest. So somewhere we have these like iterate directories. That's where we're going to want it, right? We're going to want somewhere, we're going to have like projects, termy, and in here, I'm going to want to say, show my filter of like open tickets, right? We're going to have something like this. So this is going to be like a user-defined thing, open tickets, which means that whoever iterates a directory is going to have to present that thing. That makes sense? So we can, I think it's called readdir. Yep. So how does this readdir work? We list directory contents. And in here, okay, right. So we have this concept of we have like path purposes that we keep track of. So we say like, you know, this is the root, and project or like items, it goes to items, and like relationships goes to relationships. And this is so that we can like reuse this, like, how to say this? When we generate this path, we know what we want it to be. And so like making this mapping means that we can like map it back easily later. So we're going to have a path purpose. I guess we don't need to add one yet. We don't really know what we're going to be doing there. Oh, I guess we do. We're going to be adding one that's like named filter that shows items filtered for this specific item. So we can say like item filter. That's probably going to need the item ID, right? We're probably going to be doing this like when I'm within the Termy project and I'm trying to apply this filter. Knowing that I'm in the Termy project is going to be relevant, right? Because I want to say like, show me children of Termy that also have this other trait. So keeping track of the ID is important here. And the filter ID also makes sense. Okay. I don't know if the filter ID is going to have to be like separate. Like we might need to do like an item filter ID. I don't know if we're going to be able to reuse the same filters we're currently using at the root. I don't know if we're going to be able to use those for project specific ones, but we'll try reusing for now. And if that doesn't work, we'll fix it later. Oops, I just knocked over an empty Pepsi can. Oops. Maybe I should throw out my garbage sometimes. Okay. So we now need to use this item filter somewhere. So everywhere we use filter, path purpose to file type. So an item filter is going to be a directory, I think. I'm pretty sure that makes sense. We're going to have a directory of things that we're filtering for this item. Okay, where else do we use this guy? So in the root of our file system, we present filters. But for us, we're going to be showing it in a specific item path. So I think that's this one, path purpose item. Directory associated with a given item ID, seems right. So here, we're going to have to say, hey, database. Item filters is going to be something like, database, could you please get me the filters associated with this item? That seems reasonable. Get item filters. And maybe we pass in our item ID. And he will know which conditions match this item under the hood. Is that the responsibility of the database? Maybe that's the responsibility of us. So maybe we say like conditional filters. Conditional filters. Right? We'll say, hey, get me all the conditional filters. And then, like, which ones match me? So we could maybe say, like, conditional filters matches for filter and conditional filter. Maybe we'll call it conditional filters. Or, sorry. For conditional filter and conditional filters, we could do something like if conditional filter matches ID, then we do something. But knowing if it matches is almost certainly going to require a DB lookup, right? We're going to be looking at like, you know, we might have like a thing that's like, how do I say this? So we might say if child of project project 1. And so we might have that like 1 is a parent of 2, and we might be looking at like, well, so we're item 2, so content filter matches 2 is true, but we have to look up if it's child first. So I guess we're also going to have to pass in the database here. Maybe. I think that's reasonable. So either we do like this way where we say like, okay, we'll like get the conditional filters and try to match them using the database, or you can say, hey, database, it's your responsibility to match them. And I think I like this better because I kind of want to keep the the more things that I add to this database class, the more complex it becomes. I would prefer it if I could keep the database layer thing there as like almost like purely translation between database and types, right? I think that would make things simpler, maybe. So I think that's reasonable. And then if the conditional filter matches for this ID, then we need to present the filter in our directory. So we would do something like I guess we could do this as like a iterator mapping. So you could do like conditional filters into iter map item or filter for each ID, for each filter where filter matches ID and self DB. Is that right? So we want to show only the ones where yep, that looks right. And then I guess we just get its name and ID. So the thing that we care about from the filter is its name and maybe just its ID, filter ID. Yeah, That sounds right. And then I guess we have to convert that into a path purpose. Yes. Yes. Item filter. And here we pass in the item ID. And this. Item ID and the filter ID, is that what we said? Yes, it is. Let, okay. So this is the, conditional filter paths, is this kind of, and then we can stick that in the output. Any reason why you don't use auto pair symbols like quotes and parentheses? Oh, those piss me off so fucking much. Those make me so mad because I hate it when any application changes what I typed because they never get it right. I mean, they sometimes get it right, but they never consistently get it right. And so I get like really irritated if like it just puts a quote or a bracket in the wrong spot. That like really pisses me off, and so I don't use it. And like when I'm using Vim, usually it's like I should be able to navigate to like where the thing should be quick enough anyways, so I don't really worry about it. Okay. So now we have this thing that like definitely won't fucking compile. But we have kind of stubbed out enough that I think I understand how I want the database stuff to look here. So maybe we put here pub function get conditional filter. No, get conditional filters. Yes. And he's going to return like a vector of conditions. We called this, we already have the word condition used. This is a single condition. So maybe we're going to have another thing that's like condition set, right? And because he is going to have like a vector of conditions inside. And then we're going to have to implement the condition set to have like these things that we're looking for here. So one of these things that he needs to have is its ID, which is going to be, I guess, a condition set ID. Which, maybe for now, we're going to call it a filter ID because we think that we might be able to reuse those. We might find out later that we can't, but for now, maybe we'll say that. And his implementation, he's going to have a function that's like, give me your ID. This looks different than how we structured the filter stuff, so I just want to look at that real quick. He has like a run filter thing on the database that takes in a set of conditions. We say get filters that gives us a vector of filters. Or filter, oh no, okay, wow, okay, we actually did end up doing the same thing. They have ID, name, and roles. That looks very similar, actually. Cool. Cool. Okay, so we have ID, and he gives me back a filter ID from self, and it's just self.id. Great. And what else did we say this guy's going to do? He's going to have a matches function, and he is going to take in the item ID, and the database. Okay. That's not what we did for the filters. We just passed in the rules directly to the database, which we might want to do again. We'll see. We will think about this. And then there's just this mapping thing, but that's fine. Okay. So we'll call this unimplemented. And somewhere we have to implement this get conditional filters thing. So I guess we'll call it down here. Pub function get conditional filters. A result. Maybe not a result for now. We'll just say it's a condition set. Okay, cool. And it's unimplemented. And so the rest, I think that it should compile now. conditional filters. Trait bounds were not met. Oh, because the condition set doesn't have int iter. Oh, because this actually returns a bunch of condition sets. Aha, yes, this returns many condition sets. Cool. Cool. Okay. So now we should get to the point where all of the APIs are like correct, except we need to fix some like pub private stuff. Cool. And expected path purpose string, found this. Okay. Oh, because where I tacked this guy on is wrong. So this is he's saying, hey, I have names of relationships. Then I have this like hard-coded stuff. And then I just want to chain in conditional filter paths as well. Like this. Reasonable. This matches function needs to return a Boolean. And he doesn't like, oh, because I need the name as well. I see. So this guy expects the path purpose and the name that we're supposed to show him with. So we can show it as like this, tuple path purpose and filter.name, I guess. Which doesn't exist, so we have to make it. Which means that this guy has to have name, string. And here we have pub function name. Returns a string. Maybe a stir if we want to get crazy. Because we're like, you know, you might not have to clone it. The caller of this guy might just be trying to look. So we can do this. Oops. At self name like this. Okay, and I'm noticing that this condition set thing looks exactly the same as the filter down here. So these might get merged later. Brother is a coding machine. I wanted to copy someone's code for file system and break my PC like 3 times. It was in kernel space. So yeah, I mean, kernel development gets a lot harder like that. This is like, okay, so let's just be clear that this file system is a lot dumber than like what you would have to implement in the kernel, I assume. Actually, I don't know. I haven't implemented a file system in the kernel. That was going to be the next thing on my operating system thing to do, was to implement a file system, and I never got there. But I imagine that it's like a little bit more complex at least. Maybe not. I guess you could imagine that the APIs that you need for user space file systems are the same, but the risks are much higher, right? If your code crashes in the kernel, you're fucked. And if your code crashes using Fuse, it's just like, oops, mount point dead. So it's not too bad. It's not too bad. Okay. Does everything compile now? We're close. Because I didn't call toString on this guy. This guy, we need to say name toString. And do you think that later I'm going to come back to this and like understand what the fuck this says? There's so much just like stuff in this one line of code. What the fuck? But we'll come back to it. Filter ID does not have the copy trait. Seems like it can, because I think it's just an I64. So I think saying this guy is clonable and copyable seems totally reasonable to me. Totally reasonable. Okay, and now in client, the Fuse client code we have at 464. When we list a directory, we now have to handle what if somebody's asking us to show us the directory of an item filter. So we can say path purpose item filter comes in with a item ID and a filter ID? What does it come in with? Yes, an item ID and a filter ID. And I guess for now we'll just say self-db run filter. I guess we have to get the filters. So this is going to look a lot like this actually. For now, we'll just, you know, we're cheating. We're taking some shortcuts right now because we're in prototype mode, but we'll just copy paste exactly the same filter code. Fix me. Run 100% duplicated with above, unsure if it will stay this way. But we should mark it so we don't forget. Okay, so now theoretically, do we compile? No, we don't compile. Fuck. Because it borrows something that outlives the current function, blah, blah, blah. So we look at 542. And here we can maybe say, oh, this is such a pain in the ass. So item ID is not copyable probably, which is making this thing a bigger pain, but it is copyable. So why doesn't it know? Maybe I have to dereference it here. Item ID cannot be dereferenced, so I have to like move it like this. But then, are we chilling then? Oh, that move works because it's copyable. Interesting. So you move like, you have like ID, item ID. You have like closure 1 is equal to like some thing, right? Something with item. And it's saying like, hey, closure 1, in order to do this, is going to compile to something like struct closure 1 data. And in here, he's going to be like, I have an ID with that is a reference to an item ID. Right? And if you write like move here, it like adjusts this to say like, no, we're not going to take in references anymore. We're going to store this as this guy. And I'm surprised that by doing this twice, it works. But the move keyword in Rust must be smart enough to say, okay, if ID is copyable, then we can copy it in without losing the original. I didn't know that. I expected this to not work. So, good job, Rust compiler. Thank you. Very nice, very nice. So we compile now. And now all we have to do is look at this matches. And this is unimplemented, but this is where like the juice goes. So what happens here? So we have this run filter thing on the database already. So, and this guy returns items that match the filter. So I guess as like a initial implementation, we can say run filter. We'll give it our filters. Or it's conditions now, but you know, whatever. And we'll unwrap it for now because we're being fucking lazy, right? And we're just gonna say, if this thing contains the item ID we're looking for, then we're chilling. No, oh, this is not solved. This is a DB run filter like this. And here we need to say this. Okay. So I can already tell that like, maybe it makes sense to like cache these in some way. Maybe not. I don't know. We'll see. We'll see. Maybe this is expensive. Maybe it's not. And it would be cool if this all just worked. Oh no, it won't because we're missing something else, I think. Somewhere we request the list of conditions. I forget where though. Here, conditional filter paths. We say get conditional filters. This is also unimplemented. Okay. So what does this look like now? We've got all the usage lined up. And wait, is this? Hold on, I feel like I'm missing something here. This guy has a filter ID and a name and a set of conditions. But we should have a second filter ID. Yes, that's what I'm missing. Aha. So this guy, when we call this, hold on. I think we're like recursing forever here. So the client, he says, hey, could you get the conditional filters? And here is the filter that I want you to run. But he's getting the same thing. So maybe we'll say ID return self.toRun. Yes. That makes sense. Except then the normal ID isn't stored. So we'll just delete this. Filter to run, we'll call it. I just want to make sure that this is like very, very specific naming. And this is just to make sure that we don't accidentally return the wrong one. Which maybe makes sense to have like condition IDs and filter IDs be separate. I don't know, but that's fine. Okay, so now we have to return these condition sets. And these come from the database. That makes sense. So he can probably reuse the same tables, I think. That makes sense. The only difference... Hold on, let's look at the database. So he has filters that have IDs and names. And then he has these no relationship filters that basically tie back a specific condition back to the filter that they're associated with. So if I want to add like a second type of filter here that is like, hey, I'm a conditional filter. Like, this table almost wants to be called like condition sets. Maybe. Then these guys are associated with a condition set, and then we have two types of filters up top or something. One, ooh, that sounds hairy. What if this guy says that he could, like, do I just write conditional as like an extra field on this table? What happens in that scenario? So we just look for filters where the conditional Boolean is true. Doesn't seem crazy. I don't think I really like that, but it's worth a shot trying to implement it that way just to see what it looks like. Oh boy, because I don't really have like a good feel for like what the like right answer here is. And so sometimes the right answer reveals itself by you doing the wrong thing. So I think it just kind of makes sense for me to like shoot somewhere and see what I don't like about it. So I think what I'm going to do is I'm going to change this filter table to have an extra field that says whether or not it's like the condition to run the filter or like the filter itself. Because they're essentially the same thing. So this filters table might actually be renamed like conditions or something. What's like, oh, hold on. Something, I'm missing a piece of the puzzle. I'm missing a piece of the puzzle for sure. Is there a way I can draw this that will like help me understand? Sometimes there is, sometimes there isn't. So we're going to have like we're going to have like condition down here. And he's going to be like, technically this is going to end up being like multiple tables, but we'll abstract it as one table for now. Condition. And okay, so when I am asking the database, hey, tell me what conditions I need to run on this in this specific scenario. Oh, so give me all list of conditions that I can run on tickets. That's what we're saying right now. So that means like we have like conditions, and he has an ID associated with him, and this guy like touches this ID. Okay. Which is what we have right now. Right? The thing I'm proposing is that I want to say, now tell me if this is a condition that I should run at the root level. Sorry, tell me if this is like a I'm trying to figure out like what is like the specific distinction between these two concepts that I don't have a strong line between them. I guess there isn't one. That's why I'm struggling. Okay. I think what I actually want to do is I want to say here are all of the like the sets of conditions I can run, and then I'll have another table. This seems more correct. Yeah, I like this. And we'll say that this is like what do we call it? Conditional filters, condition set. So we'll have like root filters here. And he can have like a list of these IDs. And then we can have item filters. Yeah. Then that say they're going to have two links to these IDs, ID1 and ID2. And this is going to be the condition that we need to run to check if this should run at all. And this is the set of conditions that we actually want to run. I'm like barely fucking speaking English. What I'm saying like makes so little sense. But I think that I can flesh it out a little better now. Okay. So we have conditions overall. And we run the conditions in two scenarios. One, should conditions. So the first scenario is, do we want to run a second condition on this item? And two is, what items match this condition? These are the two states. And we only cover state 2 right now. We're adding state 1. And so now we're kind of saying that the root filter is going to store one ID that maps to concept 2. So we're just going to say ID. But the item filters are going to store ID1, which maps to concept 1, and ID2 that maps to concept 2. I think that's right. That seems like it makes sense. Hey, so that trick from yesterday, I looked it up. That macro for array size doesn't work in functions. Oh, yeah. I mean, yeah. You're talking about that C trick we were talking about for array length. Yeah, there's some bullshit in there. I'm not gonna go back into it now. I think I'm sorry. I do want to talk about that, but I also want to keep going on this. So I think I'm gonna stay in this headspace right now. Okay. So I think this makes sense. So maybe it's time to do a little DB upgrade, which we haven't really covered before. Because I think I want to rename these tables. I think that this is becoming clearer in my head, and I don't want to get confused by the existing names. So we could do something like pub function upgrade db. And this is going to take in an SQLite connection. Okay. Which I think is mutable RustQlite connection. And he is going to, okay, maybe we will say that we are at 4240 and we're doing DB upgrade. And at some point we did new schema design. I think we get it now. Add condition flag if filter should be applied to an item. This is kind of done. We didn't really do it in that way. We didn't finish that concept yet, but okay. So the way I usually do this is I check current version. And then I have upgrade functions for vn to vn plus 1. Maybe we'll say sub like this. And then what you could do is you can say let upgrade functions equal to some set of upgrade functions that will all have the same signature. And then you can say, so we'll have what? Let current version equals unimplemented. Then we have our upgrade functions, and then we say for upgrade function in upgrade functions skip current version. We run the upgrade function. Yep. And then at the end, we assert that the, we get the current version again. And we assert that the updated version is equal to the expected version. And then we can say expected version, I guess, is going to be probably 2 now, because we were at version 1 before. Or maybe version 1, I can't remember. SQLite has a version field inside it, inside databases. I think it's maybe it's open here. We have user version here. And is it guaranteed to be 0? I sure fucking hope so. Because I didn't ever set it. Is SQLite user version default set to 0? Is this how you're supposed to use search engine? SQLite user version default. There we go. That's what I want to like. Default. No, this isn't even SQLite. SQLite user version. I feel like we were in the right spot. User version. How SQLite makes no use of it itself. See application ID, schema version pega. Okay, is schema version different than user version? This can result in database corruption, so I don't want to use this. User default. I'm going to assume that the default is 0 because that's what I'm seeing here, and I'm sure that I'm the only user of this thing. But it kind of worries me that it might not be well defined, and I should. Next time I make an application, think about that and explicitly set it to 0 initially. Okay. So I'll make upgrade v0 v1. And he's going to take in this connection like this. Oopsies. I want the whole thing in the brackets. Boom. It says user version is not used by SQLite itself. Yeah, I get that. But, like, does that mean that they just don't, like, is SQLite guaranteed to, like, zero out the memory of the, like, of the database before it starts? Like, therefore kind of giving it an implicit default version, you know? Like, I've always seen it be 0, but I don't know if it's, like, guaranteed. That makes sense. And we're going to have to say, like, get version is going to take in a connection. This, boom. I wonder if this whole thing should actually be modeled as a transaction, not a connection. That makes more sense. And do transactions, like, is there some sort of type I'm supposed to use that's, like, both a transaction and a connection? Impl.star for transaction. Impl deref for as connections. Maybe that just kind of works out. Maybe these guys just don't come in as connections. Maybe they come in as references to connections. Hold on, you're writing a file system? Well, we've got like the pieces in here already. We've kind of worked on this one for a little bit before. I'm just jumping back onto it because I was trying to use it in real life and it kind of sucked. I never understood inodes. Luckily, we don't need to. So we're using this library called Fuse, which is like user space file system something. User space file systems. And because like I'm not actually like doing the concept of mapping files to blocks on a hard drive. I'm writing like a virtual file system that maps files to like concepts. And so I don't have to worry about like, you know, tracking like blocks with nodes and being like, oh, this inode is associated with this file. Or I don't have to do that because I can just like write code that does what I want. Probably fuck user space file system. Yeah, probably. Okay, so how do I get the pragma? It's something like pragma user version. I think it's just this. Yeah. So I can just say connection.execute. Pragma user version. Except I need to like get the value out, which I think means that I have to. This gives me a result of a usize. What is the usize? Convenience method to prepare and execute a single SQL statement, blah, blah, blah. Example with positional parameters. So he says execute this thing. And this says how many rows rotates. That's not what I want. I want like something more like query. So I just have to prepare. All right. And then query. How do I do this? Prepare. And then query map. query map item. I guess I'm expecting a single item. So maybe query returning rows, mapped rows, query row. Takes you a query that is expected to return a single row. Yeah, this is what I want. Convenience method. Yes. So there's no parameters. And then row, I just expect row.getZero. Let ret as an i64 so that it knows, and ret. There we go. And then here I say like this, and I say, okay, ret. Boom, boom. Okay. And then I unwrap this. And there we go. This guy returns an i64. Cool. Which means that here I can say current version is get version connection. Boom. Expect version 1, blah, blah, blah. Skip current version. Can I actually do this as a usize? Looks like it. Nice. So this is get version connection now. Okay. And yeah, we're chilling. This should be a usize. Okay. And this should be assert EQ, not assert. This, boom. Okay, and now we just have to do the upgrade. So what do we want to do here? Execute batch. Okay. So we want to do something like... What do we want to do? We want to like rename the filters table to connections. So SQLite rename table. Is that like something that we can do? Alter table, table name, rename to new table name. Alter table filters rename to conditions. Okay. Okay. And then we wanted to create table root filters. Yep. We're going to create a table of root filters. And God, my SQLite SQL is fucked. My brain does not work. Create table ID name. Boom. Okay. Yes. Yes, 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 yes. Okay. So we say create table thing with the stuff inside. So create table, root filters, and we're going to say remote or ID is integer, primary key. And then can we also say that the, how do I do foreign key constraints here? I put it inside the brace. Foreign key, this. Foreign key. Was that it? Foreign space key. ID references. Conditions ID. Okay. I think that's right. Yeah. And then I close the brace. Cool. And we also have to pre-populate this data with all of the old filters. So insert into root filters ID from, I think, insert into from SQLite. Insert into table you can blah, blah, blah. No, insert into this, insert into this. I want to do it from a select. Insert into this, select this. Okay, yeah, yeah. Insert into blah, 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 select ID from conditions. Right, so every single condition before was a root filter. Now we're recopying them in, and now we just have to make the same thing, but this is going to be item filters, and we're going to say that the first ID, which is like should run, is going to be a foreign key. Yep. And then we're going to say filter is another one, which is also a foreign key. Yes, filter. This is, yeah, filter references conditions ID. And I think I don't want, I think I actually want this to be condition set, not conditions. Yes, condition set. Okay, I think that's reasonable. I think that's reasonable. And now all of the code previously that used to look for filters now needs to be changed to look for condition set. Okay. So this is fine. Filters, 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 blah, 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 blah. Okay, I think that's it. And then I also want to rename this no relationship filters thing to no relationship conditions. So rename, so this is no relationship condition filters. Rename to no relationship conditions. I think. Nope, not this one. This is, fuck, that's the initial creation of the v0, so we don't want to change that. No relationship conditions. Yep. Yep. Okay. And that's fine. It would be nice to be able to rename this like filter ID thing as well. Can I rename column in SQLite table? Is that like allowed? You can now use alter table to rename a column. Rename column to this. Okay. So we just go back to this alter table, and we're going to say rename to this alter table no relationship conditions. Rename column. This is going to be filter ID 2. Condition ID. Yep. And then we can go and look for all uses of filter ID related to this guy. And we'll just call him condition ID, I guess. Okay. And then last thing to do is pub function generate v0db. Okay. And we'll take all of this stuff that we did in the constructor before and stick it over here. So that's all of this. And I guess he's going to return a result nothing or an OpenDB error, because that's what it returned before. And this is transaction, just to keep the names the same. And at the end we write, okay, this, and now we have to create the database if it doesn't exist. So when we construct the database, we say if it doesn't exist, we create the directory, we open the thing, and then what do we do here? What do we do? We do something. We have to check if okay, here's what we'll do. We'll call this version 1, even though it's technically the same as version 0. And we'll say we're going to upgrade to version 2. Okay. And then we'll get the version. And the first thing is going to be generate version 1 db. Yes. Yes, yes, yes. And then you can say upgrade v1, v2. So that way, the old code will run if we're on version 0, but only if we're on version 0. And this guy also has to, at the end of this, transaction execute, he needs to say pragma user version is equal to 1. Okay. And then we need to specify no parameters here. Nice. And then here we also have to do pragma user version is equal to 2. All right. Okay. This guy has mismatched types, which is surprising. Oh, because this guy returns results here. So, we're just gonna, how do we do this? This guy's gonna return a result for now of OpenDB error, and we're just gonna have to fix this. That's fine. Fix me, update type. Okay. So if we did everything right, this should compile, and our tests should not crash. And I expect them to crash because probably I made just some typo somewhere. Certainly. Certainly. And I did. So no such table of relationships. And here, no such table of relationships. Oh, because we didn't create the... I'm a dumbass. We didn't run the function. Like this. And we actually want to do it on the transaction. There we go. Now? Maybe? No. Why? Foreign. Near foreign syntax error. So this is at 309. They don't like the foreign key. So I guess we should maybe kind of try to reduce the complexity here. So, oh, it's just this. I forgot a comma. I'm pretty sure it's just a comma. We'll try it again. See if it still crashes. Now they don't like that the expected version is 1, but it should be 2. Okay, so we'll just fix that. Boom. And shockingly, everything, all of our like tests for the database still pass, which means that like the upgrade looks like it worked reasonably successfully. And so now what we can do is we can run this guy on the existing database and see if what comes out is reasonable. So can we like reload? How do I F5? Oh yeah, okay. Cool. So now we have what we want. We have the root filters, and does he have... He has the existing filter ID. Nice. We actually have to write a database upgrade test, so we're just going to have to say fix me db upgrade test, maybe? Maybe not. Maybe it gets test implicitly by the other tests that we write. IE, but we do want to test like e.g. do root filters stay consistent with previous filters. Okay. But we've already spent too much time on this. So I'm going to take a break, not take a break, but like not worry too much about unit testing that right now, because I'm pretty sure it worked. And now we can implement get conditional filters. And now it's easy, right? Now we know okay. Sorry, brain. So we have now the ability to extract what we want. So we say, do we need to do a transaction here? I don't think so. So we can say self connection query. No, prepare. And what are we going to do here? We're going to say, could you please get me a list of the conditions in that new table that we added. This no relationship conditions. Select star from no relationship conditions. No, what am I saying? It's, sorry. My brain's fucking fried. Item relationships, no. Item filters, that's what I'm looking for. Should run. Is there a bracket here when I do select? I think no. Should run and filter from item filters. Yep. Okay. And then we say self let, what is this? This is let filters, this. And then we say filters dot something. I don't know what. Query map. We query map this so we can say for each row, we are going to get the two IDs. So we're going to say let should run condition set is equal row dot get 0, and this is I64, and this is a filter condition set is getting position 1, and we return should run condition set and filter condition set. Seems reasonable to me. Query map takes two things. We need to pass in the params. The params is the first argument. Okay. Filters statement is called. Okay, and then we should have a function to extract the filters for this ID. This is get filters. Can I call like get filters for ID? No. And this is actually should be called get condition sets now. Which means that we need a function like pub function get root filters, which is going to look very similar to what we have now. Okay, I think it's starting to come together. So here we're going to have get root filters, and he's going to do the same thing, except he's going to do them from the root filters table. Yes. So we're going to say select ID from root filters. And here he's going to have one thing. Okay, boom, 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 boom. And then he's just going to call, for now, get filters, find, into iter.find, filter ID. No. Does he not have the ID on him? Struct filter. He does. Filter ID. Because I have to unwrap this, that's why. Is equal to our ID. And we'll unwrap this for now. For now. This is a bug, but it's fine. And let red is equal to this, and then okay red. And do these guys not implement equal? Oh, because this guy's an I64, so this has to be filter ID like this. Like this. Boom. Cargo check. What's it bitching about now? What's it bitching about? Expected struct filter ID found result mapped rows blah blah blah. Right, so this will be unwrapped. Oh my gosh. Filter ID found mapped rows closure. Found the closure, blah, blah, blah. So, like, why did this... Do I forget how to use query map? Let query, is this query map? Ah, it's an iterator. So... I see. So we want to say collect. So this is going to be root filter IDs is a bunch of filter IDs. So yes, yes, yes. Okay. Unimplemented. We're getting closer. We're getting closer. This is part of the process. Part of the process is just blindly typing shit and seeing what the compiler yells about. So he's saying that we have an iterator of item result, filter ID, resculator. Okay, so we can just say, we want this to be collected into a result thing, and then I unwrap that. Perfect. Perfect. And then we can do the stuff. And we actually can't do this anymore. We want to say filter for if the filter is in this. We can say root filter IDs contains filter ID. Perfect. Perfect. And this guy has to be like this, and this guy is no longer an unwrappable thing. He is. Oh, it's a collect. Okay, this guy cannot borrow self because he's borrowed here, which is fucking annoying. So we can do this, put this in a scope so that we can say let root filter IDs is equal to this thing, and then the like fucking thing gets dropped, and then we don't need to worry about it. No method name contains on this because I need to remove that semicolon. This type must be known, so he needs to be flagged as vec filter ID like this. Boom, boom, boom. Okay. We got there. We got there. So that's how you get the root filters. And so this is how we're going to get the conditional filters. We're going to do the same shit. Same shit. I don't like the name of condition set anymore. I want this to be called, like, item filters. I think. Because they're semantically different. Is Rust that much better than CVP? Just want to hear your take. Okay. So I can kind of loop in the previous question here, how long I've been programming for. I can loop this in. So I did, like, C++ programming for, like, I don't know, like 7 years, maybe more, right? Like I did it in university as a co-op, and then I did it like professionally for like 5 years at one company, and then a little bit more at another company. So done a lot of C++. My take on Rust is that it's like C++ for a certain type of developer, I guess. So it's like a new C++, I guess is what I would call it. So the thing I don't like about C++ is that I never can fucking guess what it's doing. Like, you call any API in the standard library, and you have to look it up. You just don't have a choice, right? Or else you'll do something like you'll call std remove. Actually, let's enum set ft equals cpp, right? You're gonna do something like function remove elements. Int main. This is how you write C++, right? And you're going to do something like, I have like a vector of ints, and I have like, 1, 2, 3, 4 or something, right? And if I do something that seems really sane, like std remove if, and you say like, you have like your, my syntax is all wrong here. Auto A is equal to this. This is how you do this, I think. Yeah, this looks right. Right, you do something like remove if A begin, A end, and you pass in like my condition, right? And you say like, this takes in an item, int A or item, and you just say like, remove items, we'll call it X. Remove items where X is less than 3, right? This seems like a totally reasonable function to call. But then you go, holy shit, right? You look up the docs for this, and what this actually will fucking do is this will take your vector A, and your A will now equal to 3, 4, 1, 2. Or like undefined, I guess. And then this guy returns an iterator, and you have to do something like a.remove it to a.end or something. And it's like, I would never, ever remember, like, well, I do remember this now because it's so fucking crazy. But I feel like the C++ is just full of shit like this, where it's like, the thing you expect to happen is just not what actually happens, and you get bit by it with, like, not just, like, bad behavior, but, like, this will, like, just leave your vector in an undefined state. Who the fuck would want that? Why does that exist? And I get why it exists, right? It's because, like, the std remove if is working on iterators, and the iterators don't know how to remove items from the vector, so they just swap them to the end, or, like, you know, swap in stuff from the end to here and just have, like, maybe they're duplicated at the end. Like, it makes sense, like, the implementation, but it's just, it's full of stuff like this, right? Another one that always gets me is, like, std async, this function that's like, hey, run this function, right? Like, some expensive shit, right? You have, like, this function. This, one, won't run async, right? That's, like, insane, right? Unless you write, like, something like policy async somewhere. I don't remember the exact terms, but it's like, it doesn't actually do it async. And it returns a future, right? So you can say, like, return some expensive shit. That's fine, right? Except every other future in the language, if you were to just, like, return here without using it, this would just, like, live forever. But if you, like, fucking just draw, like, in this specific scenario where you called std async, if you return here, this function will block until some expensive shit finishes. It's like, why the fuck does that happen, right? There's just so much stuff in C++ that's like that. And so, like, when I write Rust, one, I find that when I guess what something does, I'm right. Two, the people who write Rust are, like, really fucking neurotic, right? So they make their types, like, really, they have a lot of, like, type shit going on, which makes it really nice when you're like, what does this guy return? Oh, it returns this type. What can I do on this type? Oh, every single thing I can do in this type is valid. Because, like, there's no, like, inconsistent state in, like, the majority of Rust libraries. And three, usually when I finish writing a program in Rust, well, I shouldn't say usually, but, like, the chances that it works are, like, very, very, very high. Where in C++, I always felt like the chance of my program not fucking crashing when I finished the first time was like 10%. Because I'm just like, you just always forget something, right? And so, like, you know, is it better? It's better for some stuff, right? I like it a lot better. It's my language of choice for a reason. But, like, it's like those things are, like, huge to me, right? The things that suck about Rust are that you just can't express some things that you can express in C++, right? The reason that, like, Rust, like, makes it so much easier to write a program that works is that, like, you can't do a bunch of the stuff that doesn't work. But in C++, you can, like, use that ability to do bad shit to, like, skip steps that you know are okay, right? It's hard to express in Rust, like, the idea of, like, I have, like, some struct A, right? And he's got, like, items, and he's got, like, a vector of ints, right? And if you wanted to, like, in this be like most important int and have him be, like, a pointer to an int and items, right? Something like this. Like, this type of thing is, like, very, very, very hard to express in Rust. And so, like, the usual way you work around it is that you go, like, oh, well, instead of storing most important int as a pointer, I'll store it as, you know, usize, like, an index into this thing, which, like, works for vectors but doesn't work for other things, right? Like, there's all sorts of, like, gotchas in Rust that you have to, like, know about. You should know the same gotchas in C++, but the consequence of not knowing them in C++ is that your program crashes sometimes, but usually not. And, like, the consequence in Rust is you can't fucking do it, and it's like pisses you off. So sorry, I try not to get into these like language language fight things, but anyways, that's why I use Rust. C++ is great for a lot of stuff as well, though. Okay, what the fuck was I trying to do here? I got distracted. Distracted. Is it worth learning Rust as a career? I will say that I've never applied to or seen a job posting that like, well, I haven't really like looked for jobs that much. I'll say that, but like I haven't ever seen a Rust job that I was like going to work on. Like, so I don't know if that's changing over time. But yeah, I don't know. So I would say, I will say that when I learned Rust, I think my C++ got a lot better. Right now, Rust is actually really high tier jobs. Oh, that's pretty cool. I didn't know that. I haven't looked for a bit, so. I'm also of the opinion, I think, keep in mind that hiring managers are not of this opinion. But I'm of the opinion that language shouldn't matter for hiring, right? If I was in charge of hiring, I would not focus so hard on a single language, but more on concepts and hope that in an interview I'm capable of like understanding what the person I'm working with is like capable of understanding, if that makes sense, right? Like if they're good problem solvers, the language isn't going to be a big blocker. But of course, if you're picking up your first language, it's a much bigger blocker. But once you've picked up 2 or 3, the 4th and 5th are really easy. Anyways, I was trying to do some work. What was I trying to do? I was trying to get conditional filters. So I have these. This is going to look similar to this. This root condition one is actually going to be where I start now. And just instead of looking at root filters, we're going to look at item filters, I think is what it's called. And these guys are going to have the should run ID here. And the filters to run over here is the first and second thing that we get. Okay, and we say should run ID and filters to run. Okay, and so now we can say this is going to look a little different, I guess. So we're going to get the filters. Let all filters self-get filters. Boom. And here it's like a little more complicated. So here we were just saying, hey, give me all of the ones where the root, where it's like one of these. But here we want to like match them, I guess. So we're going to do something more like for what should run. This is not root filter ID. Fuck, where did my cursor just go? This is not root filter IDs anymore. This is item filter IDs, and this is gonna be filter ID and filter ID. Yes, like this. Unwrapping like it's Christmas. I'm gonna use that. That's a good one because I do that a lot. Studies show Rust devs are smarter on average. There's no fucking way, right? Right? I don't know what studies those are, but I'm not going to allow that type of propaganda in this chat. I don't know, like, what I would imagine. I mean, I'd have to see the study, but I imagine that any study that's claiming that, their methodology has got to be suspect. Like, there might be some sort of correlation where people who are more into learning niche languages are more into programming in general. That might be like some signal, but there's no fucking way that I would think that people who code in Rust are smarter than any other language. That's like that's like so against my worldview. But maybe my worldview needs to be adjusted if I'm wrong. Okay, should run ID, and the other thing is like filters to run, I guess. Should run and filters to run in item filter IDs. And we're going to say all filters find, iter find, should run. And we're going to unwrap like it's Christmas. And we're going to assume that we can find this thing. And we're going to find it instead based off of filter. And, do we even need the filters here? What do we do in our matches? Run filter on the conditions. Yes, we do. So we retrieve the condition. So should run ID is equal to filter ID. Okay. And we'll say let should run conditions. And this is should run ID. There we go. Okay. So now we have the conditions, and we can say that we have the condition set. So we have condition item filter, sorry. And this is to run is the filters to run. Yep. The name is... Oh, fuck. I guess we'll call it should run conditions name. That seems fine. Reasonable. And the conditions is the should run conditions dot rules. There we go. Some name mismatches there, but overall fine. And then we'll say let ret is equal to vec new. Okay. This is mutable, and ret push this guy, boom, boom, and boom. Cool. We're close. This guy has to be mutable for some reason. Why? Because get filters is mutable. Okay. Which means that this guy already was mutable. Chillin'. And I guess that also kind of means that this, like, get filters thing should be a private function now, because we don't... Why did the maze just crash? Fuck you, maze. Come back. Because we don't want people getting, like, the raw list of filters anymore. We only want some getting... We only want people externally seeing them in the context of root filters or item filters. Okay. Okay. So where are we broken? So everywhere we called get filters before, we should call get root filters. Get filters. This is get root filters. Get root filters. Get root filters. Okay, and back in the database. 724. This guy needs to be cloned, and this guy needs to be cloned. Maybe. Fix me probably needless clone. Because there should be a one-to-one match of conditions and filter, like the ones that we saw in the filters, so this is probably unneeded, but, you know, we're taking shortcuts because we're prototyping. And that's the way it goes. Should be one-to-one mapping between item, filter, IDs, and all filters. Yeah. Okay. Now the only thing that we're missing is a way to insert a conditional filter. I think. Well, if that's all we're missing, then we actually should be able to do something kind of interesting here. Let me think. Sorry. Brain. I think that we can do something interesting here. So let's run the file system just to make sure that, like, all of our changes didn't, like, heavily break something. So we go in here. We crashed, so definitely not good. No such column ID. Can I cargo test? Do my tests still pass? Did I, like, ruin something by mistake? They still all pass. But, so, no such column ID. So this is in 710. Ah, so it's here. Ah, because this doesn't exist. Right, so this is, what are my tables here again? Item filters should run in filter. Okay, let's try this again. So I need to u mount dash f to do because it broke. Sudo umount dash f to do? That's crazy. I don't have sudo. User mount dash u to do. There we go. Cargo run. We'll run it again. And now when we go in here, to do, projects, termi. Okay, cool. So everything seems to be working. Like this root filter is still correct. And now I think, let's get crazy. Let's get crazy. So let's make a create item. We'll make an item finished. And this is going to be like a sentinel item at ID 20 to indicate if a ticket is finished. And now we have a ticket here, read line support. And we're going to call this done. So this is ticket 5. Create item relationship. And we can say relationship, I don't know, it doesn't fucking matter, 1 from 20 to 5. So this should create a relationship where that ticket is now parented by both termi and the finished ticket, I think. So we should be able to go into finished, and he has readline support as a child, and termi has children that is readline support, and his parents are both finished and termi. Cool. So I now think if we just get into the database here and we get crazy, we could produce a set here that says, show me only items that are not parented by the finished state for termi. I think that's possible. Okay. So should run will use the existing filter that we're using to show projects. So can I say, fuck. But we need a new relationship that is the same thing here. No relationship conditions, but he's going to be associated with a different filter. So I think we can say filters. Condition set. Yeah, okay. Condition set 2. Insert into condition set, and we're going to insert a new name. So we're just going to say, hey, we're going to insert a new condition set name, and values is going to be not finished is going to be what we call this. Or open. We'll call them open. Fuck. How do I... Oh my god, dude, my SQL's so bad. My memory is like just fucked. Oh, values needs to have brackets around them, of course. Okay. So now we have the open filter. And if we go into filters, condition sets, we have open. Now, I want to have an item filters. We'll use the existing condition, but we need a new one here. We need a no relationship condition. So insert into no relationship conditions. And this is condition ID, relationship ID, side ID. Okay. I already forgot. Condition ID, relationship ID, side. And the values are going to be, the condition ID is going to be 2. We're associated with the open condition. The relationship ID is going to be 1. And the side is going to be, I am not... it's going to be the same as the other one. So side 1 means I have no parents that are of this relationship type. Fuck. Okay, this means that with the existing conditions, I have to make a new relationship type for finished. Fuck. Okay. So how do we do that? Oh, that's gonna be a pain. That's gonna be a pain. I don't think that I've saved anything yet, so I think it's fine. To do bin create. Oh, we'll just use a different name. We'll just use any relationship ID. We already have a bunch of them. It doesn't matter. So we'll just use relationship ID like 3. What are relationship IDs? Relationships. Yeah, we'll just use projects. Fine. 4. We'll use 4. Okay. Insert into this, blah, blah, blah. Boom. Okay. So now we have no relationship conditions or links to condition set 2 open. And so now all we should have to do is create a new item relationships or item filters. Item filters, and we have should run and filter. Yes. And the values are going to be 1 and 2. So we're going to run if we match the same condition that we're already using to show projects. And we're going to run condition 2. Fuck. Why? Why don't you like this? Oh, that worked? So now if I have item filters, should run filter. Okay. So I think if I hit save here. Ooh, moment of truth, moment of truth. So I think projects termi. Oh, fuck, he's got the wrong name. And not accessible. Okay. So we've made a couple mistakes here. But that's okay. We'll figure it out. So why is this not accessible? ls, reading directory not permitted. So I think that's in the Fuse client. We've made a mistake at item filter. This is a directory. Okay. I will note, okay, so we already have seen something interesting though, in that termi is showing this projects inside, which means that he's correctly identified that he's supposed to match, and hopefully his children do not have the projects. Yes, they don't have the projects thing. So we've correctly at least applied this condition to show the filter in this specific condition, which is great. And now all we need is to populate this directory correctly. So I guess we need to find out why that's not happening. So let's ls to do projects termi projects. Let's just see what that's bitching about. Failed to reader, failed to find filter for given ID. That's a good clue. Failed to find filter for given ID. Condition set 2, root filters 1. Okay, so we can look for where that's coming from. Failed to find filter. Ah, because we're calling get root filters. And this is wrong. 100%. We didn't implement this section. Okay, wait. We're chilling. Where's the code where what matches? Here. Okay, so we can say get root filters. Oh. Hold on. This get root filters, maybe get filters doesn't need to be private. And we can just call this function get all filters. Okay, we're getting closer. Because externally, we do still need to run that code. So here, on our filters, we're going to say get all filters. And now it might work? Maybe. It might. Projects, termi. Ah, okay. So now it's showing all items that do not have a parent of finished. But I think we're missing a very crucial second step. So I think this should show us every single ticket except for wait, hold on. Items, projects finished. Ah, yeah. So this is showing us all, yeah. This is showing us every single ticket except for the one. Wait, read line? No, it's showing it there. Oh, because we didn't add the, I forgot. Create item relationship. We just need to, we said we were going to be using item relationship 4 or 3 or something? 4. Okay, so now if we go back into here, we should be showing every single one except for a read line. Yes, there's no read line here, but there is read line support. Nice. I think that's working to some extent. I think that's working. So there is a problem here where this should be only showing children of the project termie, right? Which means that we need another filter on this to say, please only if your ID matches the ID we passed in or something. But I think that's a lot of progress for today. And my head hurts. And so I kind of want to like just kind of give it some time to refresh and come up with the next steps. But I think that's pretty sick. So what we did today was we like adjusted database to have both root and item filters. Item filters are like root filters, but are applied to items based on a condition. That's what we did. And that was like pretty complex, I think. There was a lot to think about there, but I think I'm pretty happy with where this ended up. So now we're very close to being able to say, I'm going to child to this finished like tag item. And all I need is like another condition. So that says we need to hook up and not parent it to this. Cool. I'm pretty happy with that. Yeah, I think we'll call it there for today. So thanks for watching, guys. If you liked what you saw, I stream most days around 1 or 2 o'clock Pacific time for 1 or 2 hours. We're covering a variety of topics. Right now, we're working mostly on a terminal emulator. But I was taking a quick look at this because I've been trying to use this to like manage stuff, and it's not really like covering all the cases I need. So probably tomorrow we'll be back on termie. Pretty sure. We'll be working on trying to get less to work correctly. If you're watching on YouTube, there's a Twitch link in the YouTube description. You should swing by and say hi. And if you're watching on Twitch, there's a YouTube link and a GitHub link. GitHub will show code that like gets published from this stuff, and YouTube, all these VODs will end up there, and they're kind of like sorted into playlists for like which project you're interested in or whatever. Yeah, I think that's it. Thanks for watching, guys, and I'll catch you on the next one. Bye!